our journey leaves behind the vast Egyptian desert. We witnessed how math played a key role in the emergence of civilization. And 2 millennia later, it had a new start in the islands of Greece. The men and women there learned to argue with logic. Math was their weapon of choice. It was in ancient Greece that math was instilled with a new spirit. But this episode takes us to a country further to the east. Where the greatest revolution in mathematics occurred. It exists, yet it signifies nothing. Come to think of it, it might be more natural if it didn't exist. In this country, buildings have a 0 floor. This is indeed the home of the number 0. How and why was the number 0 created? Shall we take a step back in time in search of its origins? This neighborhood is bustling with noise and energy. The whole of India will be like this today. People are sprayed with paint powder, but nobody gets angry about it. I can't avoid it myself. This man is going to town covering my whole face with paint. Krishna, the chief of India's gods, has a blue face. Today, they paint each other's faces like Lord Krishna. This day is Holi, the festival of colors, the largest celebration in India. The road to the temple in Mathura, in the northern Indian state of Uttar Pradesh, is always filled with people on Holi. We've been stuck here for about half an hour, even though the shrine is just around the corner. This famed Hindu temple is dedicated to Lord Krishna. This scene is amazing. The festival goers have been worshipping like this for 3 hours. A priest distributes food that has been offered to Krishna. By sharing food with this god, they feel one with him. Deities play a central role in the lives of Indians. Gods and people live together. To outsiders, this scene may be foreign and novel. How does such a deep faith exist in a scientific world? It is truly amazing. But to 1.2 billion people in India, this is as natural as eating and drinking. Holi falls on the last full moon of the lunar calendar. When this festival comes, spring begins. The festival reaches its climax during the night. People light fires and praise Lord Krishna. Holi begins on the last full moon day of winter in India. What the gods have in store is shown up in the sky, and humans must read the will of the heavens. This is the eve of the festival. The fires are not lit until the full moon appears. The people pray in order to expel any bad fortune. They do so by burning a Holika effigy, a symbol of an evil demoness. By watching such festivals, children grow up feeling close to their gods. Serving good gods and punishing bad gods are both integral parts of Indian life. The Holika collapses. The coming year will also be one of abundance. Every day throughout the year, there will be festivals somewhere in India. These festivals are a form of communication with the gods. Setting the dates of festivals was itself the beginning of math in India. It took us 11 hours by car to travel from Delhi, India's capital, to Ujjain. Ujjain is a small city located in central India. But when Brahmagupta was assigned to be the chief of this town's observatory in the 7th century AD, the place looked much different from today. Ujjain was the center of Indian astronomy back in those days. And being the center of astronomy means being the center of math. Brahmagupta, who was from Binmal in northwestern India's Rajasthan, took a long time to travel to Ujjain in India's Malwa region. He was the most respected scholar of his age. His appointment as chief of the observatory was proof of his lofty status. In those days, Indian astronomy was much more advanced than that of the West. People in India already knew that the Earth was round. They were even able to calculate its circumference with relative precision. They were off by only 100 kilometers. Brahmagupta had just arrived at the front lines of science. Although he was administering the observatory, he was in love with mathematics. But math was relegated to a supporting role for astronomy in his day. While in Ujjain, Brahmagupta's concerns eventually resolved solely on math. As astronomy developed, math in India developed along with it. Math did not exist simply for calculating large numbers for astronomy. Thanks to Indian mathematicians, we are able to do small calculations important to daily life. The ancient people of the East were more adept at calculating numbers than doing geometry. In particular, several special calculations were introduced in Indian sacred books. Examples were things like this. "94 times 97. Indians many centuries ago solved problems this way. Subtract 94 from 100. And subtract 97 from 100. Add each resulting value, 6 and 3, and take it from 100. The answer is 91. Now this time multiply 6 by 3, which comes to 18. Indeed, the result of multiplying 94 by 97 is 9,118. Indian scriptures introduce such unique calculations on many different pages. The surprising magic of Indian math played a powerful role in observing the movements of the sun, the moon, and the stars. On the summer solstice, the sun passes right through the center of Ujjain. The latitude of Ujjain is 23 degrees north. This is known as the Tropic of Cancer. Just as the Royal Greenwich Observatory is to the British, Ujjain was the center of the world to the Indians. They were able to calculate the length of 1 year to within an error of just a few seconds. They discovered another important mathematical method to observe the celestial. It is known today as trigonometry. Trigonometry is particularly useful to determine the length of something that is too high or far away to measure in person. For example, suppose we need a tree trunk to be used as a column. The top of the tree is too high to measure. I need to find a point that creates a 45-degree angle with the top. This is too close. Let's go a bit farther. I found a point that is 45 degrees with the top of the tree. The tree is standing at a right angle. The angle on my side is 45 degrees, and its counterpart angle is the same. When two angles are the same size, the length of each angle's opposite side is also equal. Therefore, the height of the tree is the same length as the distance I walked. I walked about 15 meters, so the height of the tree is 15 meters. If I walk further, the angle where I am gets correspondingly smaller. Naturally, the lengths of the corresponding sides would also change. The angle closest to me gets smaller, while the hypotenuse gets longer. When the angle closest to me is 30 degrees, the hypotenuse is 30 meters. At this moment, the ratio between the height and the hypotenuse is 1 to 2. This is the value of the sine of 30 degrees. The basic concepts of trigonometry originated with the Greek mathematician Ptolemy. But the Greeks knew sine values for only a few angles. Indians knew more about trigonometry. They made tables representing the sine and cosine values from 0 to 90 degrees. The tables almost exactly match the trigonometry values we know today. India was truly the birthplace of modern trigonometry. This is Mount Everest. In 1856, over a century before people climbed to the summit of this dizzying peak, its height was determined using geometry to be 8,840 meters. But Indians were able to measure something even farther than that with the help of trigonometry. It was the distance to the sun. During the half-moon lunar phase, the Earth and Sun form a near-perfect right angle relative to the Moon's position. And the angle formed at the Earth is 89 6/7 degrees. This is the same type of calculation we use to measure the height of the tree. The angle of the sun's point is a mere 1/7 of a degree. Since Indians knew the values of sine, they plugged in the numbers. The sine of 1/7 of a degree is 1/400th. They knew this meant that the sun was located 400 times farther than the moon. This town doesn't look all that different from Brahmagupta's time. Varanasi is an especially appealing place for tourists. India has a population of 1.2 billion people and more than 300 million gods. Varanasi contains nearly every element of India. But a country's potential is not always found in their number of people or number of gods. Tourists in India want to visit Varanasi. And those who make it here want to look around Durga Temple. There is an interesting question found in this temple. It has to do with the end of this world. There are 2 poles located in a pond at this temple. One pole holds 64 circular plates. The end will come when all the circular plates are moved to the pole on the right. But there's one condition. When moving the plates, a larger one cannot be placed on top of a smaller one. And so there is an extra pole to assist with this task. So how many moves would it take to transfer all 64 plates? Let's try moving just one of them first. Just one move is enough to transfer one plate. How about two? One, two. But this goes against the rules. A larger plate cannot be placed on top of a smaller one. One, two, three. Now, I will try to transfer three of the plates. How many moves will it take? 1, 2, 3, 4, 5, 6, 7. It took me 7 moves to transfer just 3 of the plates. 1 move for just 1 plate, 3 moves for 2 plates, and 7 moves for 3 plates. So, can I only know the answer after I move all 64 plates? I don't think so. Math is about finding rules and formulas. 1 move for 1 plate. 3 moves for 2 plates. And 7 moves for 3 plates. What is the pattern or formula hiding here? Take the number 2 to a power equal to the number of plates, and then subtract 1. If we're moving 4 plates, multiply out 4 2s, and then subtract 1. This requires 15 moves. That means that in order to move 64 plates, you must multiply out 64 2s, and then subtract 1. What is the result? The answer is 18 quintillion 446 quadrillion 744 trillion 73 billion 709 million 551,615. If I move 1 plate each second, it would take 584.9 billion years. Almost 18.5 quintillion moves, taking 585 billion years. The Indians aimed for some seriously large numbers. But no one can see the end of infinite numbers. Such extreme numbers represented an aspiration for eternity. Indians believe that life doesn't end with death, but instead repeats itself indefinitely. This life is but a brief moment among an infinite number of lives. Consequently, many care little about their looks. Indians believe that at least once in their lifetime, they should bathe in this river. They take more care with their spirits. An aspiration for large numbers resulted in unexpectedly huge numerals, which represented unimaginable numbers. In order to see how immense this unique plate-moving number was, we should compare it with numerals in other cultures. We know that one of the oldest numbering systems in human civilization was created in this part of the earth. They express numbers in the form of beautiful hieroglyphs. Just as we name new objects, the same was done with new numbers. One was a stick. 2 was 2 sticks. Numbers up to 9 were expressed with sticks. 10, 100, and 1,000 were expressed with different figures. Fractions were also created. Roman civilization emerged thousands of years after Egypt's, but their culture had many similarities. Roman numerals could get a bit complicated. These are Roman numerals. These shiny letters represent 1,828. Roman civilization created numerals in units of 5. 1, 5, 10, 50, 100, 500, and 1,000. When necessary, they created new numerals and used them. Mesopotamian numerals, Mayan numerals, Chinese numerals that even included negative numbers. These ancient peoples all created new numerals when they were needed. Natural numbers and fractions were found in every ancient civilization, and the Chinese even created negative numbers. Human civilization has been expanding its mathematical horizons for a very long period. But this innovation came last, even though it may be the most important of all. It's right here in front of me. This is a fort built about 1,200 years ago. Among hundreds of temples in Gwalior Fort, this gate is the only one with a padlock. This temple is dedicated to Lord Krishna. On a wall in this temple, we find the very thing I'm looking for. Within this scripture is recorded an offering given at the time this temple was dedicated. Among the numbers representing their offerings, 270. I came looking for 0. This 0 is the first 0 recorded in human history. Let's take a trip down memory lane, shall we?
2 ice creams. You have to count like this.
We master basic numbers at the age of 6 or 7.
2 ice creams.
The history of math seems to resemble that of human development.
These are cars, and you have.
Just as numbers emerged at an early stage of mathematical history, we learn numbers at a young age.
Right? 200.
We asked this child to write 232.
Like this.
He writes it like this. We may have forgotten it, but we ourselves wrote our numbers just like he did. It takes a lot of training to understand numbers as we use them now. It's very common for small kids to write out 200, then 30, then 2.
232 means hundreds, 30, 200.
The 2 on the left and the 2 on the right look the same, but they hold different values. That's a tough concept. Those who first accepted this found it difficult.
And again 2 is to hundreds.
Present-day numbers originated in India. The numbers we call Arab numerals were actually created by the Indians. And the numbering system with our current numerals are the invention of the Indians. Brahmagupta was a mathematician in a country that revolved around this system. The difference is that India used different symbols for each number. What was amazing in the Indian numbering system was the way to express the next number. Instead of creating new numbers for the next number, they reused numerals that already existed. The one on the right looks just like the one on the left, but their values are different. This is all because of the 0 that follows the 1. Now, with zeros following the other numerals, numbers can expand indefinitely. It was a revolution in numbering. The Indian numbering system traveled to Europe through the Arab world. This is why they're called Arab numerals. The Indians lost credit for the greatest intellectual property. This is a bill used in the African country of Zimbabwe. It is worth $100 trillion. This note has 14 zeros. Without the existence of zeros, how could we express 100 trillion? We can't imagine life without it. A lot of something might be described as being like sand on a beach. But how can we express this kind of thing in the form of numbers? These grains of sand, red blood cells, or stars in the sky. With numbers to represent these objects, we're able to move forward toward bigger and greater things. It's ironic that we're able to express huge numbers with the invention of the smallest, which is 0. Zero means nothing. Nothing is expressed with 0. This is the number created by people who saw emptiness as something. That is what 0 is. This is Sandipani Ashram. Brahmagupta conducted research and discussions with his pupils in this temple. While working as the head of the observatory, he fell in love with numbers. He tried to figure out every possible numerical result of addition, subtraction, and division. But this was not particularly practical for everyday life. Prior to Brahmagupta's time, Indian math was a practical secondary subject, a mere tool to assist astronomers and architects. But Brahmagupta began to study math as an independent field. And this led to him making the greatest discovery in the history of math. In 628 AD, Brahmagupta wrote a book while working as chief of the observatory. An astronomy book, Brahma Sputta Siddhanta. It means correctly established doctrine of Brahma. 2 chapters of this book were dedicated to math, in which he wrote 4 fundamental operations of arithmetic made with positive or negative numbers. In his numeric world, positive numbers were assets and negative numbers were debts. Let's suppose that these blue baskets represent assets and the brown ones are debts. Add more assets to the existing assets, the entire set of assets increases. When more debt is added to the existing debt, more debt is created. But what happens if the assets and the debts are combined? If the assets are bigger than the debts, there is a remainder. What if the amount of assets and amount of debt are equal? There is nothing left. Prior to Brahmagupta, every mathematician finished their study at this point. But Brahmagupta decided to call this zero. By doing so, zero took its first steps into the world of math. Brahmagupta was the first mathematician to insert zero in calculations. Other people didn't understand math formulas using zero. They believed that zero wouldn't play any role in calculations because it doesn't change the results when you add or subtract it. It is difficult for us to understand why he put zero into his calculations. He was well aware of the nature of math. That is, to find principles behind the objects and not just their use in everyday life. The zero like we find in 2012 did exist prior to Brahmagupta. But zero began to be used independently when it was a part of calculations. Brahmagupta knew the hidden meaning of zero that was crucial to these calculations. Its power came from equations. I'm going to show you what equations can do. Imagine a farmer who raises cows and chickens. Combined, the total number of these 2 animals is 19. Their total number of legs is 62. So how many cows and how many chickens does the farmer have? If you keep trying out number combinations one by one, eventually you'll find the answer. But with the advent of the zero, there came about a way to find the answer quickly and easily. Cows and chickens together make up 19 animals. Cows have 4 legs, and chickens have 2. In total, there are 62 legs. Represent cows and chickens as X and Y respectively. Now, remove Y from each side of the upper equation. This becomes zero. Without doing this, it's impossible to calculate further. Now, insert the value of X into the lower equation. The number of cows is 12, and the number of chickens is 7. Many aspired for an eternal world, but only the philosophers who thoroughly realized its emptiness could possibly reach such a world. It was through math that this realization could be expressed in human language. It was the greatest innovation in the history of math. The zero took a long journey west through Arabia. It took 8 centuries for Western culture to assimilate the zero. In the summer of 2010, mathematicians from around the world gathered in India. They are here for the International Congress of Mathematicians, an event that takes place every 4 years. Around 5,000 world-class mathematicians have been invited. The world focuses on the winner of the Fields Medal, the international medal for outstanding discoveries in mathematics awarded at this Congress. It is known as the Nobel of Mathematics, and it's awarded to young mathematicians under the age of 40. Through this event, we can see how the current state of math is evolving. The President of India emerges. It is a tradition for the head of state of the host country to welcome all the mathematicians. That's an indication of how important this Congress is. The first winner of the Fields Medal this year is Elon Lindenstrauss of Israel. His accomplishments lie in the area of ergodic theory and its applications in number theory. He used equations to prove his theory in his dissertation. These awards are particularly meaningful since they are being given in India, the country that discovered the zero. Vietnam, Russia, and France each produced a winner. The country with the most Fields Medal laureates, the highest award in mathematics, is the USA. This reminds us of the influence of math on a country's potential in the world. The next International Congress of Mathematicians in 2014 will take place in Seoul, South Korea. We expect a new revolution in math to take place there.